Long before the towering dinosaurs came to dominate vast stretches of our planet, Earth was already a stage for creatures both strange and formidable. To fully appreciate the breadth of prehistoric life, one must set the stage far beyond the yardsticks that are the dinosaurs, those iconic reptiles that have captured popular imagination. The history of life on Earth spans hundreds of millions of years, a vast timeline filled with extraordinary forms, from primordial microbes to astonishingly large invertebrates and ancient vertebrates that preceded, coexisted with, or succeeded the age of dinosaurs. Our journey begins deep within Earth's ancient past, in the eons before the first dinosaur roamed. The Earth itself was a very different world. Its atmosphere, climate, and geography have undergone dramatic transformations, shaping the evolution of life in ways that often seem alien to our modern eyes. The story stretches back to the Paleozoic Era, starting nearly 541 million years ago, marked by incredible diversification of marine life during an event known as the Cambrian explosion. This period laid the foundation for complex ecosystems and introduced a dazzling variety of organisms. Long before the rise of dinosaurs in the Mesozoic Era, the seas were ruled by peculiar and sometimes monstrous creatures. Ancient oceans teemed with arthropods, early fish, and massive cephalopods, the ancestors of modern squids and octopuses, some of which dwarfed any animal we see today. These early marine titans, the likes of which may seem stranger than fiction, were the apex predators of their time. On land, the stage was slower to set for the large vertebrates. The first terrestrial ecosystems were dominated by plants and smaller creatures, including vast forests of early vascular plants that transformed the atmosphere by increasing oxygen levels. This oxygen boost during the late Paleozoic supported the evolution of gigantic insects and arthropods, creatures that would be nearly impossible to find in today's world due to the significant shift in atmospheric composition. Amphibians emerged from the water, evolving into the first tetrapods, ancestors of all land vertebrates, setting the stage for the incredible creatures that would follow. Then came the age of the synapsids, often called mammal-like reptiles, some of which grew to terrifying sizes and bore fierce adaptations that made them formidable predators in their ecosystem. Among these, some species sported massive sail-like structures along their backs, mysteries that still intrigue scientists today. Understanding Earth's prehistoric past beyond dinosaurs requires us to delve into the Permian period, ending around 252 million years ago, which witnessed the greatest mass extinction in Earth's history. This cataclysmic event wiped out nearly 96% of marine species and 70% of terrestrial vertebrate species. Yet, from this devastation, new groups would eventually rise, including the ancestors of dinosaurs and mammals. It also showed the ever-changing and often harsh realities of Earth's ecosystems, where giant creatures both thrived and perished. The journey through prehistoric Earth is not limited to land, for the oceans hold tales of creatures that inspired legends of sea monsters. Giant armored fish known as placoderms, enormous sharks, plesiosaurs with their elongated necks, and formidable mosasaurs carved their niche in the vast marine realms, embodying forms and hunter adaptations that often surpassed the most fearsome dinosaurs in direct threat. Meanwhile, the skies of prehistoric Earth were not empty either. Before birds took to the air, pterosaurs claimed the skies, some with wingspans larger than small airplanes. These reptiles mastered aerial hunting and soaring long before the evolution of modern birds, painting a picture of Earth's past as a place of dynamic and diverse giants, each adapted exquisitely to their environments. As we set the stage here, it's crucial to appreciate the profound scale and diversity that life on Earth has exhibited over millions of years. Dinosaurs, despite their grandeur and dominance, represent just one chapter in an epic saga filled with creatures that, like shadows and echoes, haunt our understanding of the past. Many prehistoric beings were just as terrifying, strange, if not more so, than the dinosaurs themselves. In this exploration, we will travel through time and space, from the depths of ancient oceans swarming with ruthless hunters, through forests where colossal arthropods crept, to skies ruled by gigantic flyers, and rivers patrolled by crocodilian giants. We will meet creatures that challenge our imagination and redefine the very notion of prehistoric terror. Tonight, as you relax and drift toward sleep, let your mind journey into these ancient worlds. Worlds where life took on incredible forms, where survival demanded extraordinary adaptations, and where the things that roamed the earth were not only bigger or stronger, but often stranger and more relentless than the dinosaurs we've come to know. Here begins our passage through Earth's prehistoric past beyond dinosaurs, a vast realm of wonder, awe, and a touch of ancient fear. Throughout the vast tapestry of Earth's deep history, life has been punctuated and transformed by profound and sometimes cataclysmic events known as mass extinctions. These moments of crisis reshaped the biosphere on a scale that can be difficult to fully grasp. They not only erased vast numbers of species, but also cleared ecological stages, paving the way for new and often unfamiliar giants to rise. Understanding these extinction events offers a crucial glimpse into how monstrous creatures beyond the dinosaurs emerged, thrived, and sometimes vanished from our planet's great story. Mass extinctions are defined as relatively brief periods in geological time, usually millions of years or shorter, when the rate of species loss greatly exceeds the normal background extinction rates. In Earth's history, scientists have identified 5 major mass extinctions, sometimes called the Big Five, each with distinct causes and consequences. Our journey through these cataclysms begins at the end of the Ordovician period, about 444 million years ago. Though less famous than later extinctions, this event wiped out an estimated 85% of marine species. It was driven primarily by severe glaciations and a major drop in sea levels, which devastated the shallow marine habitats where much of life resided. This extinction reset the stage in the oceans and led to evolutionary experiments with new marine forms, setting a pattern of ecological upheaval and opportunity. More dramatic still was the late Devonian extinction, another series of pulses around 359 million years ago. This prolonged event struck primarily marine ecosystems, eliminating many species of reef-building organisms and silencing once powerful predators. The ripple effects of this extinction were profound, including the decline of the massive armored fish known as placoderms, some of the fiercest creatures of their day. Afterward, various strange groups, including early sharks and primitive lobe-finned fishes, diversified, laying groundwork for future marine giants. Yet the most notorious mass extinction is undoubtedly the Permian Triassic event, often called the Great Dying, which occurred roughly 252 million years ago. This cataclysm was unparalleled in severity, eliminating about 96% of marine species and 70% of terrestrial vertebrates. Volcanic eruptions, climate change, oceanic anoxia, oxygen depletion, and possible methane release combined with devastated ecosystems worldwide. The aftermath was a barren world, a blank slate in which new forms of life would arise. It is precisely in the wake of these extinctions that we observe the birth of some of Earth's most unfamiliar giants. The devastation broke old ecological strongholds, enabling previously minute or suppressed groups to diversify and often grow to enormous sizes. Take, for instance, the early Triassic period following the Great Dying. Enormous amphibians and synapsids emerged, some bearing strange body plans and massive proportions unlike anything seen before. In this new world, both terrestrial and aquatic ecosystems evolved with a fresh cast of unusual predators and herbivores. Some of these beings were heralds of a new age, ancestors to groups that would eventually give rise to dinosaurs, mammals, and other vertebrates. However, many lineages developed unique adaptations and forms so bizarre and gigantic that they seem more frightening than the known dinosaurs. Massive amphibians, for example, occupied swampy environments as apex predators. The temnospondyls, some stretching up to 6 meters, 20 feet, wielded powerful jaws and robust limbs capable of both aquatic and terrestrial hunting. Their grotesque appearance, with broad heads and crocodilian features, places them among prehistoric giants that were predators before the reign of dinosaurs truly took hold. Meanwhile, in the oceans, the aftermath of mass extinctions often birthed new giants among marine invertebrates and fishes. Cephalopods, relatives of modern squids and octopuses, evolved an array of titanic species, including straight-shelled nautiloids that could grow dozens of meters long. These creatures, with their sleek, elongated shells and multiple tentacles, hunted fiercely in the primeval seas, inspiring some of the earliest settings for tales of leviathans and sea monsters. Similarly, early sharks and other cartilaginous fish began to dominate niches left vacant by extinction. While the modern mind associates sharks primarily with the later Megalodon, prehistoric epochs featured a remarkable range of these animals, often far larger or more specialized than any present-day species. Their teeth, jaws, and fins adapted to hunt in diverse environments, from shallow waters to deep ocean trenches, making them fearsome components of the prehistoric food chain. On land, the synapsids, often referred to as mammal-like reptiles, not only survived some mass extinctions, but flourished post-Permian. Diverse forms evolved, including those with towering sails on their backs, believed to help regulate body temperature or serve as display structures. Among these giants, some species had formidable bite forces and hunting strategies, predating the rise of true mammals by many millions of years. An important consequence of mass extinctions and the subsequent evolutionary radiation was that many newly emergent giants possessed features and adaptations that inspired modern horror and fascination. Their alien anatomies, sometimes bearing armors, enormous claws, or massive jaws, underscore a world where competition and survival produced monstrous forms beyond our common imagination. The cyclical nature of extinction and renewal showcases the resilience and inventiveness of life on Earth. From the ashes of lost species rise the spectacular, sometimes terrifying. These periods of rebirth often harbor species that can outmatch dinosaurs in size, ferocity, or sheer unfamiliarity. This evolving panorama of life extends further into later extinctions, such as the Cretaceous-Paleogene extinction that ended the reign of the non-avian dinosaurs about 66 million years ago. In their aftermath, mammalian giants grew to enormous sizes, and new marine apex predators emerged, creatures that, while distant from dinosaurs, rivaled or exceeded them in many respects. As we move forward in our tale, it becomes clear that mass extinctions are not just periods of loss, but birthplaces for new ages of the giant and the strange. Understanding these dark turning points in Earth's history helps us appreciate the diversity and complexity of prehistoric life beyond the well-known dinosaurs. It reminds us that Earth's history is a story of constant change, where monstrous creatures evolve repeatedly, thriving in worlds as alien to us as any science fiction. Now, with this foundation laid, we turn our gaze towards the terrifying abyss of the ancient seas, where some of the most unfathomable marine nightmares first took shape. The oceans, vast and mysterious, nurtured giants whose shapes and sizes would boggle the human mind, setting a new frontier for prehistoric fear. Long before dinosaurs dominated the land, before the forests rustled with the footsteps of massive reptiles, there was a time when Earth's seas ruled supreme, vast, deep, and teeming with life forms that were often stranger and far more terrifying than any creature that stalked the ground. This was an era when the oceans were nature's grandest arena, a realm dominated by monstrous predators and enigmatic giants whose shapes and behaviors still inspire awe and mystery today. During the Paleozoic and Mesozoic eras, spanning hundreds of millions of years, marine ecosystems experienced some of the most fascinating evolutionary experiments in the history of life. From the Cambrian explosion, a period of rapid, in the vast expanse of Earth's ancient oceans during the Devonian period, approximately 358 to 382 million years ago, an apex predator emerged that was unlike anything seen before, Dunkleosteus. This prehistoric fish, belonging to a group called plecoderms, captures imaginations for its armored body and terrifying biting power, earning it a reputation as one of the most formidable marine creatures to ever swim the seas. To understand the terror invoked by Dunkleosteus, we must first picture the Devonian world itself, often called the Age of Fishes. This era was marked by extraordinary diversification in aquatic life. It was a time when the seas were dominated by a stunning variety of fish species, including early sharks, lobe-finned fishes, which were beginning to explore land, and the heavily armored placoderms, with Dunkleosteus arguably reigning supreme among them. Dunkleosteus terrelli, the largest known species of this genus, could grow up to 10 meters, 33 feet in length, making it a true giant of the Devonian seas. But size was only part of its formidable nature. Its most distinguishing feature was its armored head and thorax, huge plates of bone fused to form a natural suit of armor around its front body, effectively creating a helmet and breastplate. Unlike modern fish, Dunkleosteus lacked teeth. Instead, it sported amazing bony plates that functioned as self-sharpening blades. These jaw plates were like scissor blades, capable of opening and closing with incredible speed and force. Studies estimate that Dunkleosteus could bite down with a force exceeding 6,000 newtons, equivalent to the bite of the largest modern crocodiles and far exceeding that of most other prehistoric fish. This immense power allowed it to crush armored prey, as well as tear through the flesh of other predators, including other placoderms and primitive sharks. Anatomically, Dunkleosteus was a marvel. Its head armor was composed of several interlocking plates that provided both protection and a strong structural base to support its mighty jaw muscles. The rest of its body, though less armored, was robust and muscular, suggesting a powerful swimmer capable of bursts of speed to ambush prey. Fossil evidence of the tail region indicates a crescent-shaped tail fin, allowing for swift propulsion and maneuverability. Dunkleosteus also featured a distinctive jaw mechanism known as the kinesis of the lower jaw, which allowed it to open its mouth astonishingly quickly. Some estimates suggest it could snap its jaws open in as little as 20 milliseconds. This feature, combined with its blade-like jaw plates, made it arguably the fastest and most efficient predator of its time. Ecologically, Dunkleosteus was likely an apex predator, sitting atop the food chain in the Devonian marine ecosystems. Its diet probably included a range of animals, from other armored fish to early sharks, and various marine creatures with hard shells. Its powerful bite was well adapted to puncture and crush thick armor and shells, making it a dominant hunter in the ancient seas. Fossil discoveries of Dunkleosteus primarily come from what is now North America, particularly the famous Cleveland Shale Formation in Ohio, as well as parts of Europe and Morocco. These fossils reveal not only the size and structure of the beast, but also provide clues to its life and environment. The impression Dunkleosteus leaves is one of awe and primal fear. A living armor-clad giant whose jaws could snap through nearly anything. Its rare fossil preservation, often only of head plates and jaw fragments, tantalizes paleontologists with glimpses into a creature that once ruled primeval oceans with terrifying efficiency. Despite its dominance, Dunkleosteus and many other placoderms eventually vanished by the end of the Devonian period, a demise linked with the late Devonian mass extinction. This extinction event, which affected much of marine life, saw the decline of many armored fish and primitive reefs, opening ecological canvases for other groups to rise. Nevertheless, the legacy of Dunkleosteus endures in the story of prehistoric giants, a monstrous symbol of the deep's primeval power, armored in bone and lethal in bite. Its form and function challenge modern perceptions of fish and predators, evoking a deep, instinctive respect and trepidation for the ancient oceans when creatures of unimaginable terror stalked the waters. As we journey onward from the armored jaws of Dunkleosteus, we will encounter even more colossal and fearsome predators that commanded the seas in epochs following the Devonian. The oceans, ever a theater of giants and terror, reveal continuous chapters of life evolving in scale and savagery, setting the stage for supreme predators such as the ultimate great white analog, the Megalodon. In the colossal oceans of the Miocene and Pliocene epochs, spanning roughly from 23 million to 3.6 million years ago, reigned supreme one of the most feared and scientifically fascinating marine predators ever known to history, the Megalodon. This giant shark was not only a formidable hunter, but a titan of its watery realm, far surpassing in size and raw predatory power any shark alive today. As we delve into the story of Megalodon, we explore the anatomy, environment, and terrifying ecological dominance of a creature whose shadow looms large even in modern imagination. The name Megalodon derives from the Greek words mega, meaning large, and odon, meaning tooth. This shark literally meant big tooth, and its fossilized teeth are some of the largest ever found, some exceeding 18 centimeters, over 7 inches in length. These enormous teeth, serrated and tricusped, were perfectly adapted for grasping, slicing, and crushing prey. Teeth like these gave paleontologists and ocean enthusiasts alike an immediate sense of the size and power of this ancient beast. Estimating the size of Megalodon has been a subject of rigorous scientific analysis and debate, relying heavily on tooth size, vertebrae fossils, and comparisons to its closest living relative, the great white shark. While estimates have varied, most experts agree that megalodons reached lengths between 15 to 18 meters, approximately 50 to 60 feet, with some hypotheses suggesting specimens even larger. To put this into perspective, that size is roughly the length of a standard city bus, making Megalodon one of the largest, if not the largest, predatory fish to have graced Earth's oceans. Megalodon's morphology resembled that of modern great white sharks, but on an immense scale. Its body was robust and streamlined, built for powerful bursts of speed to ambush prey. The jaws alone could open wide enough to swallow a small car, lined with several rows of massive teeth designed for maximum cutting efficiency. These teeth, combined with an estimated bite force of up to 18,000 newtons, could easily crush the bones and flesh of the largest marine mammals, rivaling even some of the most fearsome terrestrial predators. Ecologically, Megalodon was an apex predator in the oceans. Its diet likely consisted primarily of large marine mammals, such as whales, dolphins, and giant sea turtles. Evidence from fossilized shark bite marks on whale bones illustrates hunting and scavenging behavior, indicating that Megalodon targeted fully grown animals of tremendous size. This capacity to tackle such colossal prey redefined the oceanic food chain during its era. The global distribution of Megalodon was extensive. Fossils have been found on every continent except Antarctica, indicating a remarkably wide habitat range. These sharks occupied warm coastal waters, diving into continental shelves where their prey was abundant. The changing climates of the Miocene and Pliocene would have influenced their migratory and breeding patterns, much like modern sharks. One of the most intriguing aspects surrounding Megalodon's demise is the scientific debate about its extinction. As formidable as it was, Megalodon disappeared from the fossil record around 3.6 million years ago, possibly due to a combination of factors. The cooling of ocean temperatures, changes in sea levels, and the decline of its preferred prey were likely contributors. Furthermore, competition with evolving marine mammals such as early orcas and dolphins may have placed additional ecological pressure on Megalodon populations. Despite its extinction, the legacy of Megalodon endures. Its fossilized teeth remain iconic symbols of prehistoric power, treasured by collectors and researchers alike. These fossils not only document the sheer size of this ancient shark, but offer invaluable clues about predatory behavior, oceanic ecosystems of the past, and the evolutionary history of sharks. Megalodon's cultural impact is profound. Frequently depicted in films, literature, and documentaries, it embodies the ultimate oceanic nightmare, a creature so immense and powerful that it challenges the boundaries of human imagination. It is this mix of terrifying size, predatory skill, and mystery that continues to captivate and haunt our collective consciousness. As night falls and waves lap gently against the shore in our minds, envision the hidden depths of ancient oceans where giants like Megalodon ruled supreme. Consider the sheer force lurking behind those massive jaws, the silent, shadowy hunter beneath the waves, and the vast, mysterious world these creatures inhabited long before humans walked the earth. Our journey through prehistoric giants of the seas is only beginning. Beyond Megalodon lie other ocean titans, lurking in epochs past, whose stories unfold in the fossils and sediment of distant times. We will continue to unravel these mysteries, exploring creatures like Eurypterids, Kronosaurus, and the giant mosasaurs who inherited the oceanic throne after Megalodon's reign, each more fascinating and formidable than the last. As we delve deeper into the ancient oceans, uncovering their shadowed depths, we encounter a group of predators so immense and powerful they seem more myth than reality. Pliosaurs. Among these marine giants, the Eurypteridon stands out for its imposing size and formidable hunting prowess. Often called the monster pliosaur, Eurypteridon ruled the seas of the Middle Jurassic period, approximately 160 to 155 million years ago. Its legacy is one of awe-inspiring scale, razor-sharp adaptations, and a terrifying dominance that would have rivaled, if not surpassed, many of the prehistoric creatures from the land. Pliosaurs belong to the broader clade of plesiosaurs, marine reptiles distinct from dinosaurs, yet no less fearsome. While plesiosaurs are typically remembered for their long necks and smaller heads, pliosaurs were characterized by massive skulls and powerful jaws, built for efficient predation. Their bodies were streamlined for speed and strength, with 4 large flippers, ideal for swift and agile movement in the vast Jurassic oceans. Eurypteridon's size has intrigued and sometimes baffled scientists. Early popular accounts, dramatized in documentaries, suggested lengths of up to 25 meters, about 82 feet, making it a leviathan rivaling the largest whales of our time. However, more conservative and current scientific estimates place Liopleurodon's length closer to 6 to 7 meters, 20 to 23 feet, for most known specimens, though related pliosaurs and other members of this group did reach monstrous sizes exceeding 10 meters. Even at a moderate size, Liopleurodon was an apex predator, able to take down large marine reptiles, fish, and ammonites with terrifying efficiency. The skull of Liopleurodon was a masterpiece of natural engineering. Measuring over a meter in length, it housed powerful muscles capable of generating immense bite forces. Its jaws held large conical teeth designed to pierce flesh and crush bone, indicating that it preyed upon large, well-armored animals. The interlocking nature of its teeth and strong jaw closure suggest a strategy of ambush predation, where the animal would overpower prey quickly before inevitable escape. In terms of sensory capabilities, Liopleurodon probably relied heavily on acute vision, as implied by the large size of its eyes and skull anatomy. This keen sight would have been invaluable in the dim-lit depths or murky waters of prehistoric seas, allowing it to spot prey at a distance and execute precision strikes. Fossil remains of Liopleurodon have primarily been discovered in Europe, particularly England and France, where Middle Jurassic marine deposits preserve the bones of this marine beast alongside those of other giant reptiles and fishes. These fossils provide not only anatomical details, but environmental context, showing that Liopleurodon inhabited coastal seas rich with prey, such as ichthyosaurs, other plesiosaurs, and large fish. Ecologically, Liopleurodon was likely the terror of these waters. Its size and speed would have made it the equivalent of a modern orca, or great white shark, occupying the top of the food chain. Despite its dominance, it coexisted alongside other gigantic predators, including early sharks and other pliosaurs, creating a complex paleobiological ecosystem of competing large marine hunters. The evolutionary lineage of pliosaurs, including Liopleurodon, highlights a fascinating adaptation to aquatic life. Unlike many marine reptiles, their limbs evolved into large paddle-like flippers, perfectly shaped for propulsion through water with powerful, flexible strokes. This anatomy made them agile swimmers capable of rapid acceleration, a necessity for a predator that relied on sudden bursts of speed to capture swift prey in open water. Interestingly, Liopleurodon's relatively brief reign and the appearance of even larger marine reptiles toward the late Jurassic suggest a marine arms race, an evolutionary competition driving these predators to greater sizes and more specialized hunting tactics. It is in this context that we begin to glimpse the rise of pliosaurs that dwarfed even Liopleurodon, such as Pliosaurus and perhaps even the colossal Predator X, which may have reached lengths of 12 to 13 meters or more. Despite its fearsome reputation in popular culture, it is essential to separate scientific evidence from exaggeration. The fascination with Liopleurodon has been fueled in part by dramatic documentaries portraying it as a gargantuan sea monster capable of swallowing entire marine reptiles whole. However, in reality, Liopleurodon was a predator perfectly adapted to its niche, large, powerful, and efficient, but part of an ecosystem teeming with diversity. Today, Liopleurodon serves as a testament to the unparalleled diversity and strangeness of prehistoric marine life. In the vast oceans before the origins of modern marine mammals or sharks, these giant pliosaurs were the ultimate predators, combining brute strength, speed, and evolutionary sophistication. Their reign offers a mesmerizing glimpse into a prehistoric sea world dominated by extraordinary creatures whose scale and ferocity continue to inspire awe. As our mind drifts further across the ancient oceanic landscape, the journey takes us to the late Cretaceous seas, where even more massive and specialized marine reptiles like Kronosaurus and the Mosasaurs took the helm of these underwater empires. These successors to the likes of Liopleurodon pushed aquatic predatory dominance to new limits, setting the stage for a final chapter of gigantic marine terror before the rise of modern oceanic ecosystems. As the Cretaceous period unfolded, lasting from about 145 to 66 million years ago, the Earth's oceans were home to some of the most formidable and awe-inspiring marine predators ever to exist. Among them, Kronosaurus and the giant Mosasaurs stood as undeniable masters, rulers of the seas, whose dominance rivaled and perhaps exceeded that of the largest creatures to roam the land at the time. These giants of the deep not only continued the legacy of prehistoric marine terror, but also carved new evolutionary paths in the never-ending story of life beneath the waves. Kronosaurus, named after the ancient Greek titan Kronos, fittingly embodies a creature of overwhelming power and size. This pliosaur, an enormous marine reptile closely related to the previously discussed Liopleurodon, inhabited the early Cretaceous seas about 125 to 100 million years ago. While many pliosaurs possessed formidable proportions, Kronosaurus truly pushed the boundaries of predatory scale. Fossil evidence, primarily from Queensland, Australia, and parts of South America, reveals that Kronosaurus grew up to an estimated 10 to 12 meters, 33 to 39 feet, in length, placing it among the largest marine reptiles of its time. Its skull alone could measure over 2 meters, housing massive jaws lined with sharp, conical teeth adapted to grasping and crushing prey. This reinforced skull anatomy allowed it to generate enormous bite forces, sufficient to easily dispatch sizable prey, including large fish, other marine reptiles, and possibly even turtles and ammonites encased in tough shells. Kronosaurus's body was compact and muscular, with 4 powerful, paddle-like limbs that propelled it through the water with remarkable speed and agility. Unlike earlier pliosaurs that displayed greater flexibility in their flippers, Kronosaurus likely relied on powerful strokes and bursts of speed to ambush prey in the shallow or open waters it inhabited. Its relatively short neck and massive head made it an efficient and highly specialized predator, creating an unbeatable combination of strength and precision. Transitioning into the late Cretaceous, the mosasaurs emerged as a diverse and highly successful group of marine reptiles that would come to dominate the oceans until the end of the Cretaceous epoch. Once considered close relatives of monitor lizards, mosasaurs were fully adapted to life in the water, with elongated, streamlined bodies, strong tails resembling those of modern sharks, and limbs transformed into flippers. The apex of this group included colossal species such as Mosasaurus hoffmanni, Tylosaurus, and Haenosaurus, some of which rivaled or exceeded Kronosaurus in size. Lengths of 12 to 17 meters, 40 to 56 feet, were not unusual for these giants. Mosasaurs were formidable swimmers, capable of chasing down swift prey, which ranged from fish and squid to other marine reptiles and even seabirds. Mosasaurus, in particular, has captivated the scientific community and popular culture alike. Possessing powerful jaws filled with robust, sharp teeth, it could crush shells and bones alike. Some fossil evidence suggests that mosasaurs could generate bite forces comparable to those of modern crocodilians, but combined with greater speed and flexibility. Their sense organs, including advanced vision and perhaps electroreception, made them highly effective hunters in the often murky or dimly lit marine environments. Ecologically, mosasaurs filled a crucial apex predator role in late Cretaceous seas, shaping marine food webs by preying on a wide variety of taxa. fossil stomach contents have revealed remains of fish, turtles, ammonites, and even other mosasaurs, hinting at complex trophic interactions, including possible cannibalism. One of the more remarkable aspects of mosasaur evolution was their adaptation to various marine environments, from shallow coastal regions to deeper offshore waters. The streamlined body plan, complete with a powerful tail fluke and paddle-like limbs, made them highly versatile and capable of long-distance swimming and deep diving. The eventual extinction of these marine giants coincided with the dramatic Cretaceous-Paleogene extinction event around 66 million years ago. This global catastrophe, caused by a combination of an asteroid impact and massive volcanic activity, brought about the end of the reign of not only dinosaurs on land, but also the disappearance of mosasaurs, plesiosaurs, including the likes of Kronosaurus and many other marine species. Yet their legacy is preserved through the fossil record and the evocative stories they tell. Kronosaurus and giant mosasaurs symbolize a time when reptiles mastered the oceans with unparalleled ferocity and adaptability. Their size, power, and specialized anatomy remind us that the seas of the past harbored monsters whose dominion rivaled and, in many senses, exceeded that of the dinosaurs on land. As we move forward in our exploration of prehistoric giants, the realm of aquatic terror continues to beckon with creatures of strange forms and formidable presence. From the armored jaws of Devonian fish to the massive predatory sharks of later eras, the oceans have consistently been a theater for some of Earth's most extraordinary and terrifying life forms. The story of Kronosaurus and mosasaurs is just one vivid chapter, a testament to the powerful, sometimes monstrous nature of prehistoric life beneath the waves. Long before the reign of the largest marine reptiles and titanic sharks, Earth's prehistoric oceans were patrolled by some of the earliest and most fearsome arthropods to ever exist. The eurypterids, commonly known as prehistoric sea scorpions. These creatures, belonging to a group of ancient chelicerates related to modern scorpions and horseshoe crabs, thrived from the Ordovician through to the Permian periods, roughly 460 to 252 million years ago. Their presence as dominant marine predators long predates the arrival of dinosaurs, and their astonishing size and adaptations make them some of the most fascinating and indeed terrifying invertebrates in Earth's long history. Imagine vast shallow seas and coastal habitats dominated by vast carpets of algae, reefs in their infancy, and ancient fish sparingly filling the waters. Into these watery realms crawled or swam eurypterids, creatures ranging from modestly sized predators to true giants. Some species exceeded 2 meters, over 6 feet, in length, dwarfing any modern-day arthropod and casting significant shadows over their domains. Eurypterids exhibited remarkable morphological diversity. Most were somewhat streamlined, with large, segmented exoskeletons that protected their bodies but still allowed for flexibility and swift movement. Their bodies were divided into 2 major sections: the prosoma, head, and the opisthosoma, abdomen, capped by a sometimes formidable telson, a tail spine that could serve as a weapon or a rudder for swimming. Equipped with powerful spiny appendages near their heads, eurypterids were adept hunters. These limbs functioned like grasping pincers or spears, allowing them to seize prey with remarkable strength. Their compound eyes were prominently positioned on their heads, granting them keen vision to detect prey or predators alike in often murky or dimly lit waters. Among the most famous genera is Jekalopterus, whose fossils have been found in Europe and North America. This sea scorpion reportedly reached lengths up to 2.5 meters, over 8 feet, making it one of the largest arthropods to have ever lived. Such massive size combined with formidable claws and an armored exoskeleton, placed Dicalopterus at the apex of its ecosystem, capable of preying on a variety of marine organisms, including fish, smaller eurypterids, and perhaps even early amphibians. The hunting strategy of eurypterids combined ambush and active predation. Their powerful, spiny appendages were efficient in grabbing and immobilizing prey, while their tail could be used for quick directional changes or even defense. Some species were excellent swimmers, undulating their abdomens or using paddle-like limbs to maneuver through the water with surprising agility. Eurypterids also left their mark on the sedimentary record, often preserved well enough to reveal details about their ecology. Fossil trackways suggest that some species could come onto land, perhaps to molt or escape aquatic predators, hinting at a fascinating lifestyle bridging marine and terrestrial environments. The Ordovician up to the end of the Silurian periods saw eurypterids at their peak diversification, both in size and ecological breadth. Their fossils have been discovered worldwide, from the shallow seas of what are now North America and Europe to regions of Asia and Australia, indicating their widespread success in various marine environments. However, despite their dominance, eurypterids faced challenges from the growing diversity of fish and early terrestrial vertebrates. By the late Devonian and into the Carboniferous period, the rise of new marine predators and ecological shifts gradually diminished their stature. Mass extinction events and increased competition ultimately led to their decline and extinction by the end of the Permian, coinciding with Earth's most devastating mass extinction. Yet, the legacy of these giant sea scorpions is undeniable. They provide a glimpse into a prehistoric world where arthropods attained sizes and ecological roles now unimaginable among their modern descendants. Their terrifying claws, enormous size, and predatory prowess make eurypterids some of the most remarkable marine hunters in Earth's history. As we continue exploring the grandeur of prehistoric giants, it is important to remember that terrifying predators were not confined to vertebrates alone. Arthropods, like the eurypterids, remind us that evolution has crafted monsters in every lineage, some far stranger and more fearsome than the dinosaurs that came later. With that in mind, our next chapter will take us into the mysterious depths of the ancient seas, where colossal cephalopods such as Orthoceras and Cameroceras reigned supreme, creatures blending both otherworldly design and predatory efficiency that would have tested the oceanic might of any hunter they encountered. Long before the age of dinosaurs, during the Paleozoic era, Earth's oceans were inhabited by remarkable and enigmatic creatures that would lay the groundwork for the cephalopods we know today. Among these early mollusks, the orthoconic cephalopods, most notably Orthoceras and Cameroceras, stand out as some of the most formidable marine invertebrates, whose enormous sizes and sophisticated adaptations made them apex predators in worlds both alien and fascinating to our modern sensibilities. Orthoceras, which means straight horn, is one of the most iconic ancient cephalopods, characterized by its long, straight shell. These animals lived approximately 485 to 390 million years ago, during the Ordovician and Silurian periods. Unlike the coiled shells of modern nautiluses, Orthoceras sported elongated, tapering conical shells that could reach impressive lengths, some specimens measuring over 2 meters, around 6 to 7 feet. These shells were divided internally into a series of chambers connected by a siphuncle tube, allowing the animal to regulate buoyancy and move vertically within the ancient seas. The shells themselves, now commonly found as fossils in sedimentary rocks worldwide, were often beautifully preserved, revealing fine details of growth lines and internal partitioning. Beyond their aesthetic appeal, these structures were critical to the animal's survival, granting the ability to hover stealthily in the water column or pursue swift prey. Cameroceras, closely related to Orthoceras, but truly a giant of its time, has fascinated paleontologists for decades. Emerging in the Ordovician period approximately 470 million years ago, Cameroceras is considered one of the largest cephalopods known from the fossil record. While complete specimens are rare, estimates based on fossilized shell fragments suggest that some individuals may have grown up to 6 meters, around 20 feet, or more in length, making Cameroceras a colossal presence in primeval seas. The sheer scale of Cameroceras, combined with its presumed hunting prowess, likely made it a dominant predator, capable of preying on a variety of marine life, including early fish and smaller invertebrates. Its squid-like body would have been housed in the shell's initial chamber, with long tentacles used to grasp and immobilize prey. This mode of hunting resembles modern cephalopods, but on a scale that surpasses our wildest imaginations. Both Orthoceras and Cameroceras possessed tentacles lined with powerful suckers or spines, enabling them to secure prey quickly amidst the underwater currents of ancient oceans. They were likely an essential part of the marine food chain, playing roles akin to today's squids and octopuses, but with far greater mass and reach. An important aspect of their biology was the chambered shell, which functioned as a buoyancy control device, filled periodically with gas or fluid. This innovation allowed these animals to traverse depths and maintain precise control over their vertical positioning, facilitating hunting ambush tactics or strategic retreats from larger predators. Despite their massive size and dominance, these orthoconic cephalopods were not invincible. They faced threats from large armored fish and other marine predators of the Paleozoic seas. However, their agility and ambush strategies likely offered a significant edge. Fossil evidence provides a tantalizing glimpse into their lives and environments. Orthoceras fossils are widespread, found across continents in limestone deposits, indicating that these creatures thrived in a variety of marine settings, from shallow reefs to deeper offshore waters. Cameroceras, though rarer, appears in similarly diverse ecosystems. Preserved bite marks on contemporaneous fossils suggest interactions, both predatory and defensive, with other marine organisms. As evolution marched onward, the orthoconic cephalopods gradually gave way to more advanced coiled-shelled relatives like ammonites, and eventually the ancestors of modern squids and octopuses. Their extinction by the end of the Paleozoic allowed these newer cephalopods to rise, but the monumental legacy of Orthoceras and Cameroceras remains embedded within the fossil record. Their colossal shells and the mystery enveloping their biology capture the imagination and inspire awe. Through these fossils, we glimpse a primeval ocean where invertebrates ruled in monstrous forms, where the balance of power was measured not in scales and bones alone, but in tentacles and buoyant chambers, controlling the dance of life beneath the waves. Moving forward from these colossal cephalopods, the oceans continued to teem with supersized sharks, vertebrate predators that would rise to dominance both before and after the reign of the mighty Megalodon. These sharks, with their evolutionary innovations and terrifying hunting capabilities, link the ancient invertebrate terrors to the vertebrate giants that shaped marine ecosystems in epochs to come. Spanning hundreds of millions of years, the lineage of sharks reveals a fascinating evolution marked by both modest forms and gargantuan predators that ruled the oceans long before and after the reign of the legendary Megalodon. These supersized sharks, evolving through epochs of changing climates, tectonic shifts, and ecological upheavals, offer us a continuous narrative of adaptation, dominance, and sometimes extinction. Understanding these marine leviathans illuminates not only the story of Megalodon, but also the broader history of oceanic apex predators. The story begins in the deep Paleozoic seas, where the earliest sharks emerged roughly 420 million years ago during the Silurian period. These first sharks were relatively small compared to later giants, but even in early times, their evolutionary innovations set the stage for future dominance. Their cartilaginous skeletons, paired with keen sensory systems like the ampullae of Lorenzini, which detect electric fields, and advanced teeth capable of constant replacement, provided advantages that no other marine creatures could match. Fast forward to the Carboniferous and Permian periods, approximately 350 to 250 million years ago, where some shark species began growing to impressive sizes. Fossils indicate apex predators like Clatidus and Orthocanthus, which reached lengths of several meters, wielding sharp teeth suited to the diverse aquatic life emerging then. These early giants often had elongated bodies and specialized dentition adapted for capturing slippery prey, such as fishes and early amphibians. The Mesozoic Era, the age of the dinosaurs, witnessed further diversification and scaling up of sharks. One notable example is Cretalamna, a genus that existed from the late Cretaceous and possibly a direct ancestor to the Megalodon, with lengths estimated up to 5 meters, around 16 feet. This shark had robust teeth, perfect for grasping large prey, and occupied a high trophic level in marine ecosystems filled with plankton, fish, and marine reptiles. Megalodon, emerging in the early Miocene around 23 million years ago, stands as the zenith of prehistoric shark evolution. Its sheer size, superior biting force, and diversified diet made it the undisputed oceanic titan of its time. With fossil teeth that dwarf even the largest great whites and an estimated length of up to 18 meters, about 60 feet, it dominated vast marine habitats worldwide. But the story does not end there. Even after the extinction of Megalodon around 3.6 million years ago, sharks evolved new giants and maintained their status as formidable marine hunters. Some fascinating examples include the Carcharoccales angustidens, considered an earlier relative in the lineage of giant megatooth sharks, the Megalolumna paradoxodon, whose fossils suggest a large shark with a unique dental pattern previously unknown, and Isurus hastilis, an ancestor of the modern mako shark, notable for its size and speed. In more recent oceans, the extant whale shark, Rhincodon typus, holds the title of the largest living shark species, reaching lengths of up to 12 meters, 40 feet. However, it is a gentle giant, feeding primarily on plankton. Conversely, the great white shark, Carcharodon carcharias, though much smaller than Megalodon, retains the apex predator position in many modern marine ecosystems. Its powerful jaws, hunting strategies, and remarkable sensory adaptations make it an evolutionary success story that echoes the legacy of its prehistoric predecessors. Shark evolution also shows a pattern of repeated gigantism interspersed with periods of decline, influenced by global environmental factors such as ocean temperature, sea levels, and prey availability. For example, the cooling of ocean waters in the Pliocene likely contributed to the extinction of larger megatooth sharks, including Megalodon, as smaller and more agile predators filled vacated niches. Moreover, the fossil record reveals intriguing examples of sharks with novel adaptations. The Cretoxyrhina, dubbed the Ginsu shark from the late Cretaceous, possessed razor-sharp teeth and was a swift swimmer, attesting to a predatory niche that shared characteristics with both modern great white and megalodon sharks, bridging gaps in understanding predatory evolution. Investigating the teeth of extinct sharks often provides the clearest window into their biology and behavior. Shark skeletons are cartilaginous and rarely fossilize well, but their durable teeth persist in sedimentary archives, allowing paleontologists to reconstruct body sizes, dietary preferences, and ecological roles. These studies reveal a dynamic evolutionary saga involving fierce competition, ecological opportunity, and adaptation to shifting environmental landscapes. Reflecting on the lineage of supersized sharks before and after, Megalodon opens a broader appreciation for the evolutionary forces shaping marine ecosystems. From the armored predators of deep Paleozoic seas, through the monstrous megatooths of the Miocene, to the giants swimming today's oceans, sharks have been resilient, adaptable, and occasionally terrifying. Their story is one of constant change, survival, and occasionally extinction. As we continue our exploration of prehistoric giants, from terrifying marine beasts to crocodilian titans and giant flyers, the remarkable history of sharks serves as a profound reminder. While dinosaurs may have dominated the land, the seas have always harbored their own nightmares, ever evolving in scale, complexity, and sheer power. Deep within the mists of prehistory, long before the reign of modern crocodilians as we know them today, three colossal predators stalked the rivers, swamps, and coastal waters of their respective eras with terrifying dominance. Sarcosuchus, Deinosuchus, and Permian were giant relatives of the crocodile lineage, not merely scaled-up versions of modern crocs, but truly monstrous creatures, unmatched in both size and ferocity. To understand their lives, habitats, and predatory prowess is to glimpse into a darker chapter of Earth's past, where these apex reptiles rivaled dinosaurs and other giants for supremacy. Let us begin with Sarcosuchus, often affectionately dubbed Super Croc by paleontologists and enthusiasts alike. Living during the early Cretaceous period, about 112 million years ago, Sarcosuchus imperator was a massive crocodiliform from what are now the sands and floodplains of northern Africa. Estimates place its length at about 11 to 12 meters, 36 to 39 feet, approximately twice as long as the largest modern crocodiles, with weight estimates exceeding 8 tons. The skull of Sarcosuchus alone stretched over 1.75 meters, thickly armored and equipped with giant conical teeth up to 18 centimeters, 7 inches long. Unlike most crocodiles that employ a sit-and-wait hunting strategy, Sarcosuchus likely engaged in aggressive predation, capable of tackling large prey, including dinosaurs, that came to the riverbanks to drink. Its robust build and powerful jaws suggest an ambush predator with the strength to subdue prey weighing several tons. Fossil evidence reveals that Sarcosuchus inhabited extensive river systems abundant with fish and other aquatic fauna, as well as terrestrial dinosaurs. Its anatomical adaptations, including thick bony plates in the back, osteoderms, may have provided armor protection and helped regulate body temperature, much like modern crocodilians. Moving forward in time to the late Cretaceous, roughly 82 to 73 million years ago, we meet Deinosuchus, another giant crocodilian titan from North America. Often called the terror crocodile, Deinosuchus riograndensis was enormous, reaching lengths of up to 12 meters, nearly 40 feet or more, and possibly weighing over 8 tons. It possessed massive jaws lined with robust serrated teeth, adapted for biting through tough hides and bones. Deinosuchus coexisted alongside some of the largest dinosaurs, such as hadrosaurs and ceratopsians, and may have preyed upon these formidable creatures. Its teeth reveal a predatory strategy not unlike that of modern crocodiles, but on an unimaginable scale, biting and rotating to tear flesh from prey. Many fossilized dinosaur bones from late Cretaceous river deposits bear bite marks consistent with Deinosuchus attacks. Like Sarcosuchus, Deinosuchus also inhabited freshwater environments, rivers, swamps, and coastal lagoons, acting as a formidable ambush predator. Its impressive size enabled it to disrupt ecosystems by controlling populations of large vertebrates, positioning this giant reptile as a keystone predator in its environment. Further south, in the lush tropical wetlands of South America, during the Miocene epoch around 8 to 5 million years ago, roamed Purosaurus, the largest known caiman and one of the biggest crocodilians ever recorded. This massive creature reached lengths of up to 12 to 13 meters, 39 to 43 feet, dwarfing all present-day crocodilians, and tipped the scales at an estimated 6 to 8 tons. Purosaurus had an enormous broad snout and robust teeth designed to deliver crushing bites, capable of preying on large mammals, giant turtles, and fish in its freshwater environment. Fossils of giant limb bones alongside Purosaurus remains indicate that some of its prey might have included formidable ground sloths and peccaries, animals that inhabited the dense South American rainforests. The ecological role of Purosaurus parallels that of its giant cousins, an apex predator dominating the waterways. Its powerful bite force, estimated in some studies to exceed that of any living crocodilian, would have allowed it to exert predatory pressure over a wide range of species within its habitat. Despite temporal and geographical differences, Sarcosuchus, Deinosuchus, and Purosaurus share traits that epitomize crocodilian success: mighty jaws capable of enormous force, semi-aquatic lifestyles with reinforced swimming anatomies, and behavioral versatility enabling prolonged survival across epochs. Their extinction followed various environmental changes, such as climate fluctuations, alterations in river systems, and competition with emerging mammalian predators. Yet the fossil record preserves their formidable legacy, compelling us to reconsider crocodilians not just as survivors, but as prehistoric giants who once ruled ecosystems with an iron grip. Moving beyond rivers and swamps, our exploration next takes us to the skies, where giant pterosaurs soared above prehistoric landscapes. These featherless flyers, some of which dwarfed modern birds, opened new frontiers of gigantism and predatory dynamics, further expanding the extraordinary narrative of Earth's terrifying bygone creatures. Long before modern birds took to the skies, the prehistoric skies were dominated by a group of extraordinary reptiles known as pterosaurs. Unlike birds, which evolved from small theropod dinosaurs, pterosaurs were the first vertebrates to achieve powered flight, mastering the art of soaring and gliding during the Mesozoic Era, from the late Triassic through to the end of the Cretaceous period. These flying reptiles were not only pioneers of aerial life, but also included some of the largest creatures ever to take wing, far dwarfing even the biggest birds alive today. Pterosaurs ranged widely in size and shape, from small sparrow-sized species to the colossal giants with wingspans that could rival small airplanes. Their anatomy was uniquely adapted for flight. A membrane stretched over an elongated fourth finger formed their wings, supported by a lightweight but strong skeletal structure. Unlike birds, their wings lacked feathers. Instead, the patagium, this wing membrane, provided the necessary surface area for lift and maneuverability. Among these giants, several genera stand out, illustrating the extremes of pterosaur size and ecological diversity. One such example is Quetzalcoatlus, which we will explore in detail later. But preceding it and contemporaneous with other giant flyers were members of the Agdarchidae family, which included species like Hatzegopteryx from what is now Europe. These creatures had enormous wingspans exceeding 10 meters, about 33 feet, and powerful, sharply hooked beaks adapted for hunting on the wing or scavenging. These giant pterosaurs were not just oversized versions of small flyers. Their physiology and behavior likely reflected their extraordinary size. Their limbs were robust, built to launch their massive bodies into flight using a powerful leap, probably involving a quadrupedal takeoff, using their forelimbs alongside hind limbs to spring skyward. This contrasts with the bipedal launch of birds and bats, highlighting a unique flight adaptation among vertebrates. The lightweight construction of their hollow bones, fused skulls, and aerodynamic bodies allowed these giants to overcome the challenges of flying at such scales. Their wings, often tapered with reinforced leading edges, enabled efficient soaring capabilities, making good use of thermal currents and wind patterns, much like modern large birds of prey or albatrosses. Ecologically, these giant pterosaurs were likely apex predators and opportunistic scavengers, dominating coastal cliffs, riverbanks, and inland environments. Their diets probably consisted of fish, small vertebrates, and carrion, though due to their varied beak shapes and jaw mechanics, some species may have specialized in hunting small dinosaurs or other terrestrial prey. Their large size would have enabled them to travel great distances in pursuit of food and nesting sites, suggesting they played crucial roles in Mesozoic ecosystems, both near shorelines and further inland. Fossil evidence delineates a global distribution for giant pterosaurs, with significant remains unearthed in North America, Europe, and Asia. Their extinction at the Cretaceous-Paleogene boundary, roughly 66 million years ago, marked the end of an era of vertebrate flight before the birds took over as dominant aerial creatures. The fascination with giant pterosaurs arises not only from their impressive size, but also from the sheer contrast they present to modern flying animals. No bird alive today matches their wingspan or mass, and their unique anatomy challenges our understanding of the limits of vertebrate flight. Their lives invite us to imagine soaring skies filled with creatures possessing a blend of reptilian majesty and extraordinary evolutionary adaptation. As we trace the ancient history of giants, the pterosaurs stand as a testament to life's ability to conquer environments in unexpected ways. Monstrous shapes gliding silently through prehistoric air, the first true rulers of the skies. From here, our journey will bring us closer to the very symbol of these aerial titans, Quetzalcoatlus, the living nightmare of the Mesozoic heavens, a giant that redefined the meaning of flight on Earth. Among the gigantic pterosaurs of the late Cretaceous, one name stands out as both awe-inspiring and terrifying: Quetzalcoatlus. Named after the Mesoamerican feathered serpent deity Quetzalcoatl, this flying reptile redefined the limits of vertebrate flight, boasting wingspans so immense they challenge modern understanding of aerodynamics and scaling. Quetzalcoatlus, truly a living nightmare of the skies, soared over landscapes that were simultaneously alien and wondrous, its shadow casting dread over creatures below. Quetzalcoatlus northropii lived approximately 70 to 66 million years ago in what is now North America, a time when continental interiors harbored vast semi-arid environments with rivers and lakes. Fossil remains, mainly from the Big Bend region of Texas, reveal individuals with estimated wingspans ranging from 10 to an astonishing 11 meters, 33 to 36 feet, making Quetzalcoatlus one of the largest flying animals to have ever lived. What makes Quetzalcoatlus extraordinary is not just its size, but its anatomical adaptations. Its skeleton was remarkably lightweight, with hollow bones and air-filled spaces reducing mass without sacrificing strength. The wings were formed by a stretchy membrane of skin and muscle extending from an elongated fourth finger, supported by robust musculature that likely provided powerful wing beats and graceful soaring. Unlike many other pterosaurs with long necks and specialized beaks for catching fish, Quetzalcoatlus had a relatively short, stiff neck and a massive skull equipped with a sharp, toothless beak. This anatomy suggests a feeding strategy distinct from ocean skim feeders, implying a largely terrestrial lifestyle where it hunted small vertebrates, scavenged carrion, or even stalked along shorelines and plains for prey. Paleobiologists theorize that Quetzalcoatlus was capable of launching itself into flight from the ground using a unique quadrupedal launch mechanism. This technique involved a powerful push-off using its strong forelimbs and hind limbs, propelling the animal rapidly into the air despite its massive size. This is crucial because it debunks earlier assumptions that such large creatures could not achieve flight at all. As a predator, Quetzalcoatlus wielded a formidable beak for snatching or piercing prey, likely feeding on small dinosaurs, lizards, mammals, and possibly eggs or carrion. Its strong legs and the ability to walk efficiently on land suggest it was as comfortable stalking across terrestrial environments as it was soaring through the skies. This dual capability made it a versatile hunter and scavenger, mastering multiple ecological niches. The sheer majesty and ominous presence of Quetzalcoatlus would have been a formidable sight. Imagine a creature with a wingspan that could shade several spectators simultaneously, gliding silently above the treetops or rocky outcrops, its needle-like beak ready to strike. In the Mesozoic skies, this wasn't the stuff of legend, but stark reality, a testament to life's astonishing evolutionary inventiveness. Quetzalcoatlus's extinction coincided with the catastrophic event 66 million years ago that ended the reign of the non-avian dinosaurs and reshaped all terrestrial ecosystems. Though it vanished like many of its contemporaries, the legacy of this giant endures, etched in fossilized bones, inspiring scientific inquiry and fueling imaginations worldwide. As we reflect on Quetzalcoatlus, the monstrous pioneer of flight, our journey through prehistoric giants continues downward, bringing us back to Earth's surface, where colossal terrestrial arthropods like Arthropleura, millipedes the size of cars, once traversed, a different yet equally astonishing story of gigantism and survival in the ancient world. Imagine a world hundreds of millions of years ago, deep in the Carboniferous period, where the air was thick with humidity and oxygen levels soared far above what we experience today. The Earth was dominated by vast swampy forests filled with towering lycopsids, ferns, and giant horsetails. In this lush primeval landscape, arthropods ruled in astonishing sizes, including one creature so gigantic that it seemed to break all rules of physiology and scale, a millipede the size of a small car known as Arthropleura. Arthropleura was a genus of giant myriapods that lived approximately between 315 and 299 million years ago. Belonging to the group Diplopoda, which encompasses today's millipedes, Arthropleura took gigantism to an extreme rarely seen outside the fossil record. Fossil evidence suggests that some species reached lengths of up to 2.5 meters, around 8 feet, or potentially even longer, which is equivalent to the size of a compact car. This mass and size set it apart not just from its modern-day relatives, but from nearly all other terrestrial arthropods, before or after. To place this in perspective, the largest living millipedes today grow to mere inches long, nowhere near the colossal sizes Arthropleura attained. The key to Arthropleura's immense scale was, in part, the high oxygen concentration of the Carboniferous atmosphere, which allowed arthropods and insects to sustain larger body masses by overcoming the limitations of their respiratory systems. Structurally, Arthropleura was heavily segmented, with broad, flattened body plates that offered protection and flexibility as it lumbered through the dense forest floors and fern underbrush. Its exoskeleton was composed of chitin, which, while providing armor, also allowed articulation and movement over uneven terrain. Despite its size, it probably moved with surprising agility for such a massive invertebrate, using numerous legs, 2 pairs per segment, to navigate its environment. What did Arthropleura eat? The precise diet remains a subject of scientific inquiry, but prevailing theories suggest it was primarily herbivorous or detritivorous. Feeding on decaying plant material, spores, or possibly low-lying vegetation, it played a crucial role in the Carboniferous ecosystem, recycling nutrients and contributing to soil formation. Some studies even speculate it may have scavenged opportunistically or consumed small animal matter, though no definitive evidence supports active predation. Fossils of Arthropleura have been predominantly found in what is now North America and parts of Europe, particularly in coal-rich deposits indicative of ancient swampy environments. Trackways, fossilized footprints attributed to this giant millipede, offer remarkable insights into its behavior, revealing gait patterns and the scale of its excursions across prehistoric bogs and floodplains. The extinction of Arthropleura is thought to be linked to the end of the Carboniferous and the onset of the Permian period, when climatic shifts caused a significant drop in atmospheric oxygen levels and widespread habitat changes. These environmental pressures likely imposed physiological constraints, preventing such giant arthropods from surviving into later epochs. Despite its long extinction, Arthropleura remains a symbol of prehistoric, monstrous size and limbed power. Its existence challenges assumptions about the limitations of arthropods and invites reflection on how different the ancient Earth once was, a place where invertebrates could grow as large as cars and roam seemingly without fear. Continuing our journey through the Carboniferous skies, we move next to Meganeura, dragonflies with wingspans reaching 2 feet, another astounding example of prehistoric gigantism. These giant insects took to the air with graceful power, dominating their ecological niches and inspiring awe much like Arthropleura did on land, spinning a tale of a world vastly different, yet deeply connected to the evolving tapestry of life. In the lush, oxygen-rich forests of the late Carboniferous period, around 300 million years ago, the skies were graced by an extraordinary creature, Meganeura, the giant dragonfly with a wingspan stretching up to 2 feet, about 60 centimeters. Far exceeding the size of any modern-day insect, Meganeura exemplifies the astonishing effects of prehistoric atmospheric conditions and evolution, revealing a world where the insects soared not just narrowly above our modern experience, but at scales that seem otherworldly. Belonging to the order Meganosoptera, which includes extinct relatives of today's dragonflies and damselflies, Meganeura was among the largest flying insects known from the fossil record. Fossils discovered primarily in present-day France have allowed scientists to reconstruct its anatomy and ecological role with remarkable detail. With delicate yet reinforced venation patterns in its wings, it combined strength and agility, perfectly adapted to the aerial demands of stalking prey in dense forest canopies. One striking aspect of Meganeura is its sheer size, dwarfing modern dragonflies whose wingspans rarely exceed 19 centimeters. This massive wingspan was supported by a robust thorax packed with powerful flight muscles, allowing Meganeura to glide, hover, and dart swiftly through the ancient skies. Its body length extended over 40 centimeters, about 16 inches, with large multifaceted eyes providing keen vision, essential for tracking swift and varied prey. But what allowed insects like Meganeura to reach such colossal sizes? The answer lies largely in the unique atmospheric conditions of the Carboniferous. Oxygen levels during this period spiked to nearly 35%, markedly higher than today's twice around 21%. This elevated oxygen concentration enhanced the efficiency of their tracheal respiratory systems, which rely on passive diffusion to supply oxygen directly to tissues. With more abundant oxygen, diffusion could support larger body tissues, enabling insects to surpass modern size barriers. Ecologically, Meganeura was a fearsome aerial predator, Its diet likely consisted of smaller insects, including early mayflies, beetles, and other arthropods. Using its strong mandibles and exceptional flight agility, Meganeura could snatch prey mid-air or snare them from foliage. Its role as an apex insect predator contributed significantly to the structure and control of Carboniferous forest ecosystems. The environment of Meganeura was a verdant domain of equatorial swamps and coal forests, filled with towering lycophytes, seed ferns, and giant horsetails. These dense vegetation zones offered refuge and abundant hunting grounds, while bodies of fresh water provided breeding sites necessary for larval development. The aquatic larvae, or nymphs, of Meganeura likely resembled those of modern dragonflies, living underwater while growing and predating on aquatic invertebrates until ready to metamorphose into winged adults. Despite its dominance, Meganeura, like many Carboniferous giants, eventually disappeared as atmospheric oxygen levels decreased and global climates shifted at the end of the Carboniferous and into the Permian. These environmental pressures, coupled with evolving ecosystems and competition, drove the gradual reduction in insect size. Today's insects, though diverse and numerous, lack the monumental dimensions Meganeura once possessed. The legacy of Meganeura is a vivid reminder of the intertwined relationships between Earth's atmosphere, physiology, and the astonishing adaptive potential of life. Its magnificent flight captures the imagination, offering a glimpse into a prehistoric sky where insects ruled not just in number, but in epic scale and awe. Continuing our journey through the shadows of Earth's prehistoric terrors, we now turn to the Permian predators like Dimetrodon and the fearsome gorgonopsids, the mammal-like reptiles that terrorized ancient landscapes long before mammals or dinosaurs emerged. Their stories add an essential chapter to the saga of prehistoric giants. As our journey through Earth's deep past progresses, we shift our focus from the marine and aerial giants to the fierce terrestrial predators of the Permian period, a time predating the rise of dinosaurs by tens of millions of years. This era, spanning approximately 299 to 252 million years ago, was dominated by a range of remarkable creatures that shaped the terrestrial ecosystems with an intensity and diversity that laid the evolutionary groundwork for later vertebrate life. Among the most iconic and terrifying of these early predators were Dimetrodon and the gorgonopsids, creatures whose appearances and behaviors would terrify even the most hardened modern observers, and who cast long shadows on land long before the dinosaurs took center stage. Dimetrodon, often mistakenly called a dinosaur, was in fact a synapsid, a group more closely related to mammals than to reptiles. Living during the early Permian period, roughly 295 to 272 million years ago, Dimetrodon is easily recognized by the massive sail rising from its back, formed from elongated neural spines connected by skin. This distinctive sail has long been a subject of scientific inquiry, with theories suggesting roles in thermoregulation, visual display for mating or intimidation, or aiding in blood flow regulation. This predator varied in size from about 2 to over 4 meters, 6.5 to 13 feet in length, with powerful jaws lined with sharp, serrated teeth, perfectly adapted for slicing through the flesh of its prey. Its robust limbs and sprawling gait allowed it to dominate the swampy floodplains and river valleys of the Permian landscape. As an apex predator, Dimetrodon preyed upon amphibians, other synapsids, and a variety of smaller vertebrates, employing stealth and sudden bursts of power to catch its targets. Fossil evidence predominantly comes from what is now North America, particularly the Texas and Oklahoma regions, where well-preserved specimens have illuminated details of its anatomy and ecology. The discovery of Dimetrodon fossils alongside those of its prey species paints a vivid picture of a dynamic predator-prey relationship within Permian ecosystems. Transitioning to the late Permian, approximately 260 to 252 million years ago, the gorgonopsids emerged as some of the most fearsome predators of their time. Belonging also to the synapsid lineage, gorgonopsids evolved moderately large to giant forms, some reaching lengths of up to 4.5 meters, 15 feet. Where Dimetrodon's sail was striking, gorgonopsids were defined by their powerful jaws armed with elongated, saber-like canine teeth, a prehistoric echo of the famous saber-toothed cats that would arise much later. Gorgonopsids possessed a sleek, muscular build that suggested agility and strength. Their skulls were robust, with powerful jaw musculature enabling a strong bite force, critical for subduing large prey. These predatory synapsids inhabited a variety of terrestrial environments, from floodplains to arid regions, and likely hunted large amphibians and reptilian herbivores, possibly even competing with early therapsids that began to diversify in the same period. Fossils of gorgonopsids have been uncovered primarily in South Africa's Karoo Basin, a treasure trove of Permian life. The well-preserved fossils give us insight into their skeletal anatomy, bite marks on prey fossils, and even potential social behavior inferred from fossil site distributions. The terror these predators must have inspired is palpable when we envision their fearsome teeth and predatory prowess stalking the prehistoric wilderness. Both Dimetrodon and the gorgonopsids met their end during the dramatic Permian-Triassic mass extinction event, the most severe extinction in Earth's history, eliminating nearly 90% of all species. However, their evolutionary legacy is profound. As synapsids, they represent early chapters in the mammalian lineage, setting anatomical and ecological precedents that mammal ancestors would build upon through the Mesozoic and beyond. When reflecting on the Permian predators, it's essential to remember that though they preceded dinosaurs, their forms and hunting styles were uniquely terrifying in their own right. The sailing Dimetrodon and the saber-toothed gorgonopsids reveal a prehistoric world where monstrous predators shaped the very landscape, leaving a mark both physical and evolutionary. From swamps to arid plains, they were masters of survival and predation in an unforgiving ancient Earth. Having witnessed the terror of these Permian predators, our exploration will now press onward, venturing into the Cenozoic era where mammalian giants and saber-toothed cats emerge, bringing new terror and complexity to the story of prehistoric giants. As the Mesozoic era gave way to the Cenozoic, the age of mammals began, and with it came a new generation of predators that would terrify and dominate landscapes in ways only whispered about during the reign of dinosaurs. Among these mammalian giants, saber-tooths and bone-crushing carnivores carved a niche defined by sheer power, specialized adaptations, and predatory cunning. Their stories are tales of evolutionary innovation, lethal claw and tooth combinations, and confrontations on the vast open plains and dense forests that succeeded the age of reptiles. Saber-tooths, or machairodonts, are perhaps the most iconic mammalian predators of prehistoric times. Their fossil record spans from the Miocene through to the Pleistocene epochs, roughly 23 million to 10,000 years ago, with the most famous genus, Smilodon, existing during the late Pleistocene in the Americas. Characterized by elongated blade-like upper canines that extended well below their lower jaws, saber-tooths possessed a hunting strategy reliant on precision, strength, and the ability to deliver disabling bites. Smilodon fatalis, one of the best-known saber-tooth species, reached about 1.2 meters, 4 feet, at the shoulder and weighed up to 300 kilograms, 660 pounds, with males even larger. This stout, muscular predator was adapted for ambush, using its powerful forelimbs to grapple prey and its terrifyingly long canines to pierce through soft tissues of vital organs. Unlike modern big cats with retractable claws specialized for gripping and slashing, saber-tooths relied on robust limbs built for strength rather than speed, enabling them to tackle large herbivores such as bison, camels, and even mammoths. The remarkable anatomy of saber-tooths included reinforced neck muscles to control and stabilize their massive jaws during a kill. This specialization meant that they could take down prey larger than themselves, and their hunting style likely involved targeting vulnerable points, aiming for quick immobilization rather than prolonged chases. Alongside the saber-tooths lived another group of formidable mammals often referred to as bone-crushing beasts, primarily members of the hyenodonts and large bear-like carnivores. While not always directly related to modern hyenas or bears, these prehistoric carnivores exhibited adaptations for powerful jaws capable of cracking bones and consuming every part of a carcass. Among these, the genus Borophagus, a member of the group known as bone-crushing dogs, evolved during the Miocene epoch in North America. Borophagus species were equipped with exceptionally strong jaws and large, stout teeth that facilitated consuming bones, cartilage, and tough tissues often left unused by other predators. This niche was crucial in prehistoric ecosystems because it allowed efficient recycling of nutrients and energy. Similarly, other large carnivorous mammals, such as the dire wolf, Canis dirus, that thrived during the Pleistocene, and the formidable short-faced bears, Arctodus simus, although not strictly specialized bone crushers, possessed immense bite forces and strength to dominate their environments. These beasts exhibit the remarkable trend in Cenozoic carnivore evolution toward maximizing muscular power and dental specialization to exploit a wide range of prey and scavenging opportunities. The fossil sites of the La Brea tar pits in California provide vivid snapshots of these ancient interactions. Thousands of preserved remains showcase battles for survival among saber-tooths, dire wolves, mammoths, and other megafauna, allowing paleontologists to reconstruct these extinct communities with fidelity. Environmental shifts, particularly during the Ice Ages, shaped the evolution and eventual decline of many of these giant carnivores. Changes in habitat, prey availability, and competition, including from early humans, contributed to the extinction of many species, yet their fossils continue to tell powerful stories of predatory dominance. Saber-tooths and bone-crushing mammalian predators remain emblematic of an era when mammals took center stage as nature's most fearsome hunters. Their specialized anatomies, strategic hunting techniques, and ecological roles exemplify evolutionary responses to environmental challenges and opportunities. As we continue our exploration beyond the age of reptiles and apex marine predators, we inch closer to worlds where birds ruled the skies and giant mammals roamed, adding new dimensions to the tapestry of prehistoric terror and grandiosity. In the shadowed aftermath of the dinosaurs' extinction, a new class of terrifying apex predators arose, not with 4 legs, great claws, or massive jaws as one might expect, but standing tall on 2 legs with an uncanny presence that evokes equal parts fascination and fear. These were the terror birds, scientifically known as Forus racidae, a family of enormous flightless birds that dominated parts of South America and beyond from the Paleocene to the Pleistocene epochs, approximately 62 to 2 million years ago. Terror birds were not mere oversized versions of modern flightless birds like ostriches or emus. They were evolutionary marvels of predation, predators engineered for speed, power, and lethal hunting tactics. The largest among them, such as Titanus walleri and Kelenken guillermois, stood over 3 meters tall, nearly 10 feet, and weighed as much as a large human or even heavier, with long, muscular legs adapted for rapid pursuit. Their powerful legs ended in sharp claws that could deliver devastating blows or grip struggling prey. But it was their heads that truly set terror birds apart. They bore massive hooked beaks, sometimes more than a foot long, shaped like the bill of a raptor or a giant eagle, designed for piercing, tearing, and crushing flesh. The skulls were robust and reinforced, capable of withstanding tremendous biting forces. Their vision was likely keen, adapted to tracking prey over vast open plains, and their necks, muscular and flexible, allowed precision strikes to dispatch victims quickly. Anatomically, terror birds blended features from birds and reptiles. Although flightless, they retained the hallmarks of their avian ancestry, including hollow bones and a light skeletal frame that facilitated speed and maneuverability. Their gait was powerful and efficient, suggesting they could sprint at speeds estimated up to 50 kilometers per hour, around 30 miles per hour, enabling them to chase down runners like early mammals, reptiles, and even young or weak members of larger herbivorous species. Paleontological discoveries, especially in South America's fossil-rich plains and North America's southern regions, provide fascinating insights into these creatures' lives. Their fossilized bones and footprints reveal social behavior in some species, indicating possible pack hunting or territorial displays, adding complexity to their already formidable reputations. The evolutionary origins of terror birds trace back to the isolated continent of South America, where, for millions of years, they thrived as apex predators in an ecosystem relatively free from large mammalian carnivores. Their arrival into North America via the Great American Biotic Interchange around 2.5 million years ago introduced a new predatory player to these lands, challenging established carnivores and altering the dynamics of Pleistocene ecosystems. Terror birds likely fed on a variety of prey, including small to medium-sized mammals, reptiles, and birds, leveraging their speed, power, and lethal beak to incapacitate and dismember opponents. Some fossil evidence points to deep puncture wounds on prey species that match the shape and size of terror bird beaks, a stark testament to their effectiveness as hunters. The extinction of terror birds has been attributed to multiple factors: climatic changes leading to habitat loss, competition from placental mammals that were becoming increasingly dominant, and possibly the arrival of humans in their ranges. Yet their disappearance does not diminish their significance as some of the most extraordinary and fearsome terrestrial predators in Earth's history. In imagining the prehistoric landscapes where terror birds reigned, one conjures scenes of vast grasslands and woodlands punctuated by the thunderous pounding of their massive feet and the piercing cry of their calls, a sound as chilling as their presence. They were not merely large birds. They were living nightmares on two legs, apex hunters unmatched in speed, power, and predation. As we ripple forward through time, we encounter other mammalian giants and predators that carved their own niches of terror. From colossal bears to giant ground sloths, mammoths towering over forests, and prehistoric whales ruling the ocean's depths. But the terror birds remain a vivid symbol of how evolution can sculpt creatures both beautiful and terrifying, reminding us of the diverse forms that prehistoric life embraced in Earth's grand history. Among the pantheon of Ice Age megafauna, few creatures inspire as much awe and fascination as Arctodus simus, commonly known as the short-faced bear. Towering over modern bears in both size and presence, Arctodus reigned as one of the largest terrestrial mammalian carnivores in North America during the Pleistocene epoch, approximately 800,000 to 12,000 years ago. Its sheer size, powerful build, and adaptations for endurance hunting made it one of the most formidable predators, or scavengers, of its time. Arctodus simus is often described as a colossal short-faced bear due to its remarkably abbreviated facial structure compared to today's bears. This anatomical feature reflects adaptations for a powerful bite and enhanced jaw musculature, supporting its predatory lifestyle. Estimates suggest that adult males could reach shoulder heights exceeding 1.8 meters, 6 feet, when standing on all fours, with some standing over 3.5 meters, 11.5 feet, tall if reared up on hind legs. Their weight estimates range widely, but it's commonly accepted that they weighed between 600 to 1,000 kilograms, 1,300 to 2,200 pounds, dwarfing even the largest modern Kodiak bears. The limb proportions of Arctodus reveal its unique adaptations. Its long legs and relatively slim build, compared to bulkier bear species, indicate an ability to run and travel over long distances at sustained speeds. This contrasts with the more power-oriented builds of other giant bears. Such morphology supports the hypothesis that Arctodus might have been a cursorial hunter or a highly mobile scavenger, capable of covering vast territories in search of food. Ecological reconstructions suggest that Arctodus inhabited open environments such as expansive tundras and grasslands, where its speed and size allowed it to dominate over prey species, including bison, horses, and even young mammoths and mastodons. The Ice Age landscape was a challenging environment, vast, cold, and filled with formidable competitors. But Arctodus's adaptations gave it a commanding role at the top of the food chain. Behaviorally, debates persist regarding whether Arctodus was primarily an active predator or a scavenger. Some paleontologists argue its gigantism and speed imply pursuit hunting, where it could outpace or intimidate other predators to secure kills. Others suggest it was an opportunistic scavenger, relying on its intimidating size to steal carcasses from other carnivores, such as saber-toothed cats and dire wolves. Fossils recovered from sites across North America, including Alaska, the Midwest, and California, have provided insight into the distribution and ecological niches of this massive bear. Notably, bone isotopic analyses reveal a diet that could vary from predominantly meat-based to mixed, including plants, depending on regional availability and competition, highlighting Arctodus's adaptability. The extinction of Arctodus coincides with the broader megafaunal extinction event at the end of the last ice age, approximately 11,000 to 10,000 years ago. This period witnessed drastic climatic changes, habitat restructuring, and the emergence of anatomically modern humans, all factors likely contributing to the decline of many oversized mammals. Reflecting on Arctodus simus, one is struck by the convergence of extreme size, unique physiology, and ecological dominance that this short-faced bear achieved. It embodies the paradox of prehistoric giants, creatures built to command and outlast, yet vulnerable to the ever-shifting tides of Earth's environmental and biological shifts. In the unfolding story of prehistoric giants, Arctodus stands as an emblem of Ice Age power and mystery. From here, we will explore other epochs where giant mammals roamed, such as the famed mammoths and mastodons, whose towering forms further illustrate the incredible range and scale of ancient life on Earth. As the Ice Age dawned and Earth's climates shifted dramatically, the world witnessed the rise of a remarkable assemblage of enormous mammals collectively known as the megafauna. Amid these giants were the colossal ground sloths, creatures so immense and bizarre that they continue to captivate scientists and enthusiasts alike. Their presence during the Pleistocene epoch, roughly between 2.5 million and 10,000 years ago, paints a vivid picture of prehistoric landscapes filled with titanic herbivores whose lives and eventual extinction shaped ecosystems in profound ways. Ground sloths were members of the Xenarthra order, closely related to today's smaller tree-dwelling sloths found in Central and South America. However, unlike their modern cousins, these ancient behemoths were adapted to a terrestrial, often slow-moving lifestyle, with some species growing to sizes that defy imagination. Among the largest was Megatherium americanum, native to South America, which could reach lengths of up to 6 meters, 20 feet, and weigh as much as 4 tons, sizes rivaling modern elephants. Anatomically, these giant ground sloths possessed massive, robust limbs with powerful claws used for foraging, defense, and digging. Their skeletons reveal a sturdy build with large pelvic and rib structures supporting their immense bulk. Unlike arboreal sloths, these giants were primarily terrestrial browsers, feeding on a variety of vegetation, including leaves, branches, and possibly fruits. Their large size allowed them to deter many predators and subsist on tough, fibrous plant material inaccessible to smaller herbivores. Some species, such as Erymatherium, exhibited adaptations for rearing up on hind legs and using their massive forelimbs to grasp tree canopies, extending their feeding range. This behavior suggests that ground sloths played a significant role in shaping vegetation patterns and seed dispersal in their environments, influencing forest and grassland dynamics during the Pleistocene. Fossil remains of giant ground sloths have been found throughout the Americas, from the southern reaches of Patagonia to the southeastern United States. Their widespread distribution underscores their ecological success and adaptability to diverse habitats, including open plains, forests, and mountainous regions. The age of megafauna was characterized by an abundance of enormous creatures beyond sloths, including mammoths, mastodons, giant armadillos, and extinct relatives of bears and wolves. These communities formed intricate webs of interaction, balancing herbivory, predation, and competition. Ground sloths, with their formidable size and defensive adaptations, were key players in this dynamic. However, the megafauna's dominance was threatened during the terminal Pleistocene, coinciding with climatic fluctuations as the last ice age waned and humans began expanding their geographic reach. The combined pressures of habitat change, reduced food availability, and direct hunting contributed to the gradual extinction of many megafaunal species, including the giant ground sloths. Despite their disappearance from the living world, the legacy of giant ground sloths endures in the fossil record and in lessons about the fragility and resilience of ecosystems. Their story reminds us that prehistoric giants were not limited to the distant past of the dinosaur age, but persisted well into recent geological times, shaping and responding to Earth's evolving climates. As we continue our exploration of prehistoric titans, the next chapter will introduce mammoths and mastodons, towering ancestors of today's elephants, whose massive frames and tusks symbolized the grandeur and power of Ice Age megafauna. Their histories intertwine with climatic shifts and human expansion, revealing the complex interactions between nature's giants and our own species. In the twilight of the Ice Age, towering figures roamed the cold, grassy landscapes of the northern hemisphere, colossal mammals whose size and strength seemed to echo the grandeur of ancient giants. Mammoths and mastodons, distant relatives of today's elephants, were among the most iconic megafaunal species of this epoch, embodying both evolutionary marvel and the inexorable march of prehistoric life adapting to Earth's changing climates. Mammoths, belonging to the genus Mammuthus, first appeared around 5 million years ago during the Pliocene and flourished throughout the Pleistocene. They are best known for their immense size, long, curved tusks, and dense, shaggy coats suited to harsh, cold environments. The most famous species, the woolly mammoth, Mammuthus primigenius, inhabited the Mammoth Steppe, a vast, cold grassland biome stretching across northern Eurasia and North America. Mammoths stood approximately 3 to 4 meters, 10 to 13 feet, tall at the shoulder, and weighed between 4 and 6 tons. Their thick fur coats, along with layers of fat, provided crucial insulation against glacial climates. The iconic tusks could grow over 4 meters long and were used for defense, foraging beneath snow to reach vegetation, and social dominance displays. Fossilized footprints and dung offer glimpses into their ecology, revealing a predominantly herbivorous diet, including grasses, herbs, and shrubs. Mastodons, somewhat earlier than mammoths, belonged to the genus Mammoth and diverged from a common ancestor roughly 27 million years ago. Although often confused with mammoths, mastodons differed significantly in build and ecology. Generally stockier, with straighter tusks and cusped teeth adapted for browsing woody plants rather than grinding grasses, mastodons occupied forested habitats across North and Central America. These differences underline the varied adaptations mammals made to diverse environments. While mammoths were grazers of open tundra, mastodons were browsers of forested areas, consuming leaves, twigs, and branches using specialized molars suited for tougher vegetation. Mastodons typically reached somewhat smaller sizes than mammoths, averaging around 2.5 to 3 meters, 8 to 10 feet, at the shoulder and weighing up to 4 tons. Both mammoths and mastodons played pivotal ecological roles. Their feeding behavior influenced plant communities and nutrient cycling. Their large size and social dynamics, evidenced by fossilized family groups and herd behaviors, suggest complex interactions with their environment and other species. The ultimate extinction of these giants, occurring around 10,000 years ago for mammoths and slightly earlier for mastodons, remains a subject of intense research and debate. Climate change brought rapid warming and ecosystem shifts at the end of the last ice age, reducing suitable habitats. Concurrently, the spread of human hunters with advanced tools likely accelerated their decline through overhunting. Evidence from kill sites and butchery marks on bones highlights the significant impact our ancestors had on their populations. The legacy of mammoths and mastodons is etched not only in fossils, but also in the cultural lore of human societies who encountered these magnificent creatures. From cave paintings to folklore, their influence persists in the human imagination as symbols of prehistoric grandeur and mystery. As we continue our journey through prehistoric giants, the story of mammoths and mastodons bridges the ancient past with more recent epochs, where large mammals, including prehistoric whales like Basilosaurus and Leviathan melville, dominated the oceans. These stories offer profound insights into the resilience and fragility of life on Earth, reminding us that even the mightiest can fall, leaving echoes to inspire and fascinate through millennia. In the vast ancient oceans of the Eocene epoch, approximately 40 to 34 million years ago, a remarkable evolutionary transformation unfolded. The rise of fully aquatic mammals known as whales. Among the earliest and most formidable of these prehistoric cetaceans were Basilosaurus and Leviathan melville, titans of the sea whose enormous size, predatory adaptations, and evolutionary significance forever changed the marine ecosystems. Their reign symbolizes a fascinating chapter in the story of prehistoric giants, a world where mammals took the oceans by storm, becoming as fearsome as any dinosaur or marine reptile before them. Basilosaurus, one of the most iconic early whales, owes its name to a misleading origin: king lizard, a moniker given before its mammalian nature was fully understood. Measuring up to 18 to 21 meters, 59 to 69 feet in length, Basilosaurus was among the largest marine predators of its time. Unlike modern whales, Basilosaurus sported a long, slender, serpentine body that superficially resembled a giant eel, with a flexible spine suggesting an anguilliform mode of swimming. This unique morphology reflected its ancient lineage and partially retained primitive traits from terrestrial ancestors. Fossilized skeletons of Basilosaurus, first discovered in the southeastern United States and Egypt, revealed a fascinating combination of features. Despite its great length, its skull housed large conical teeth adapted for a fully carnivorous diet. These teeth were ideal for grabbing and slicing through a variety of prey, including large fish, sharks, and smaller marine mammals. The left and right sides of the jaws bore teeth of different sizes and shapes, indicating specialized feeding habits. More surprisingly, Basilosaurus possessed tiny but functional hind limbs, vestigial remnants from land-dwelling ancestors, a visible testament to the evolutionary transition from land to sea. These limbs, however, were not used for locomotion, but serve today as an evolutionary hallmark of whale origins. Leviathan melvillei, a prehistoric raptorial whale named after the biblical Leviathan, lived somewhat later during the Miocene epoch, roughly 13 to 12 million years ago. Its discovery in Peru unearthed one of the largest known toothed whales, with an estimated length approaching 13 to 17 meters, 43 to 56 feet. Leviathan melvillei's skull alone measures about 3 meters, 9.8 feet long, packed with the largest teeth ever found in a whale, some reaching lengths of over 30 centimeters, 12 inches. Unlike modern sperm whales, which use echolocation and primarily consume squid, Leviathan melvillei was a ferocious predator attacking large marine mammals and other whales. Its robust jaws, conical teeth, and neck muscles suggest it could deliver crushing bites capable of tearing through flesh and bone. This made Leviathan a true apex predator of its era, a massive whale with predatory adaptations reminiscent of prehistoric sharks or mosasaurs. The ecological impact of these giant whales was profound. Basilosaurus and Leviathan melvillei competed with other marine predators, including large sharks and marine reptiles fading from the fossil record. Their presence indicates a dynamic and complex marine food web, with large prey animals ranging from fish to entirely different species of whales. These prehistoric whales illustrate the dramatic evolutionary journey from small, amphibious ancestors to mighty oceanic rulers. Their adaptations, from Basilosaurus's serpentine swimming to Leviathan's formidable biting force, reveal nature's ingenuity in shaping powerful predators to thrive in the world's oceans. Their eventual extinction paved the way for the modern cetaceans we know today, a vast diversity ranging from massive blue whales to cunning orcas. Yet they remain captivating symbols of prehistoric marine power. Their fossils, scattered across ancient seafloor deposits, offer glimpses into a distant past where mammals conquered the deep, rewriting the rules of life beneath the waves. As we continue onward in our tale of prehistoric giants, we turn next to terrestrial carnivores like dire wolves and ancient hyenas. These formidable hunters carried forward the age-old struggle for survival on land, mirroring the oceanic battles once waged by giants like Basilosaurus and Leviathan melvillei, a testament to nature's relentless push toward life's extremes. Amid the sprawling landscapes of the Pleistocene epoch, a time marked by dramatic climate shifts and sprawling ice sheets, two groups of formidable carnivores roamed with relentless prowess: the dire wolves and prehistoric carnivorous hyenas. These apex predators were some of the most efficient hunters and scavengers of their era, uniquely adapted to the demands of Ice Age ecosystems. Their stories are vivid examples of the evolutionary arms race that shapes life and survival, echoing the cunning and power of prehistoric giants. Dire wolves, Canis dirus, have long captured human imagination, often romanticized and depicted as menacing predators alongside the now extinct megafauna. They lived approximately between 125,000 and 10,000 years ago, primarily in North and South America. Larger and more robust than modern gray wolves, dire wolves stood about 80 to 100 centimeters, 2.6 to 3.3 feet, tall at the shoulder and weighed between 50 to 80 kilograms, 110 to 176 pounds, with some exceptionally large individuals possibly exceeding these estimates. Their skulls exhibit broader snouts and stronger jaw musculature compared to today's wolves, adaptations that provided a powerful bite force necessary for tackling large prey and breaking bones. Dental wear patterns and fossilized remains indicate that dire wolves hunted prey such as bison, horses, ground sloths, and even juvenile mammoths. Their social structure likely mirrored that of modern wolves, with coordinated pack hunting enhancing their ability to take down large, powerful herbivores in the challenging Ice Age environments. Dire wolves' fossils are especially well represented at the La Brea tar pits in California, where thousands of preserved bones reflect not only their abundance, but also their paramount role in Pleistocene ecosystems. The stratigraphy indicates periods of environmental stress and shifts in prey populations that ultimately affected the dire wolves' survival. Alongside the dire wolves, prehistoric carnivorous hyenas, members of the family Hyenidae, played a significant role in shaping the predator landscape. While today's hyenas are mainly associated with Africa, their ancestors enjoyed a far broader geographical distribution, including parts of Eurasia and North America during the Pleistocene. These prehistoric hyenas were larger and more robust than their modern counterparts, adapted to a dual lifestyle of hunting and scavenging. Their powerful jaws and specialized teeth were designed for crushing bones, giving them access to nutritious marrow that other predators couldn't exploit. A critical adaptation in environments where competition was fierce, and carrion was a valuable resource. Fossil evidence from Eurasian deposits reveals genera like Pachyrhinocuta, which was one of the largest hyenas ever, standing nearly 1.2 meters, about 4 feet, at the shoulder and weighing up to 110 kilograms, around 240 pounds. Its incredible jaw strength allowed it to dominate carcasses and compete effectively with other large carnivores, including early lions and wolves. The coexistence of dire wolves and carnivorous hyenas highlights complex ecological interactions. While dire wolves focused on coordinated hunting and social cooperation, hyenas employed versatile feeding strategies, including cooperative hunting and scavenging. This niche partitioning reduced direct competition, enabling both groups to thrive in overlapping territories. The eventual decline and extinction of many large Pleistocene carnivores, including dire wolves and the largest hyenas, correlate with climatic changes at the end of the last ice age and the increasing prominence of modern carnivores such as gray wolves and coyotes. The arrival of humans, with their own expanding hunting capabilities and landscape modifications, likely exacerbated these changes. Reflecting on the intimidating presence of dire wolves and prehistoric carnivorous hyenas, we glimpse a world where survival required not only brute force, but strategic cooperation and extraordinary adaptation. These predators symbolize the relentless spirit of prehistoric life, a tableau of hunger, power, and the ceaseless pursuit of dominance that has echoed through millions of years of evolution. As we move forward, the story naturally unfolds to encompass the human factor, our ancestors' interactions with these majestic and terrifying giants, revealing not only the challenges faced by these creatures, but also the dawn of a new era shaped by the rise of humanity. As we reach the pivotal moment when ancient giants and early humans crossed paths, we enter a fascinating and complex chapter of Earth's history, one where the evolution of our ancestors and the existence of massive prehistoric creatures intertwined in a dynamic dance of survival, competition, and adaptation. This intersection between ancient giants and early humans represents both a clash of eras and a turning point that shaped the fate of many prehistoric species, as well as the trajectory of humanity itself. The arrival of anatomically modern humans and their predecessors coincided with the waning days of the Pleistocene epoch, a period marked by the presence of some of the largest terrestrial and marine megafauna ever to walk or roam Earth. Giant ground sloths, mammoths, mastodons, dire wolves, saber-tooths, terror birds, and massive marine predators all shared the planet with early hominins, attempting to carve out their niche in an ever-changing environment. Our earliest ancestors were hunter-gatherers, innovating tools and strategies, allowing them to survive against formidable odds. The development of stone tools, fire usage, and coordinated hunting parties empowered humans with new capabilities. These adaptations facilitated not only subsistence, but also the ability to confront and occasionally outcompete or hunt megafaunal species. Archaeological sites reveal evidence of humans exploiting large animal carcasses, with butchery marks on bones demonstrating complex processing of meat and hides. This interaction was not one-sided. The ancient giants were not mere passive victims. Many of these creatures were apex predators and formidable herbivores with defensive behaviors and adaptations. For instance, saber-tooths wielded their fearsome canines. Short-faced bears and giant hyenas were powerful carnivores, and terror birds brought speed and sharp beaks to any confrontation. Encounters between humans and these giants could turn deadly for both. The arrival and expansion of humans coincided with significant climatic upheavals at the end of the Ice Age, compounding stresses on megafaunal populations. Habitat loss due to warming climates, changes in vegetation, and increased competition for resources created precarious circumstances. Scientific consensus suggests that human hunting pressure, combined synergistically with environmental changes, significantly accelerated megafaunal extinctions. However, the relationship between ancient giants and humans was not purely adversarial. Many of these megafauna species contributed indirectly to shaping early human societies. Their remains provided vital resources: meat, bones for tools and shelter, and hides for clothing and warmth. Furthermore, the challenge of coexisting with such massive creatures spurred cultural development, cooperation, and innovation among early humans. Interestingly, several anthropological and paleontological studies hint at symbolic or ritualistic aspects related to these giants. Cave paintings, carvings, and burial sites suggest that prehistoric humans revered, feared, and mythologized these animals, integrating them deeply into their cultural frameworks. Nonetheless, the eventual disappearance of many megafaunal species, such as the woolly mammoth and giant ground sloths, marked a profound ecological shift. Their extinction paved the way for ecosystems dominated by smaller mammals and the rise of human civilization as the dominant force on the planet. In contemplating this epoch, we understand that ancient giants facing our ancestors were part of a transformative moment in Earth's history. This interplay between species highlights the interconnectedness of life and how the emergence of humans reshaped the biological and ecological landscape. Our final chapters will reflect on the reasons these prehistoric giants evoke such enduring fascination and fear. We will explore what precisely made these creatures so frightening compared to dinosaurs, and why their legacy still haunts our nightmares, linking past to present in an uneasy but captivating continuity. Dinosaurs have long held the crown as Earth's most iconic prehistoric creatures. Their massive sizes, reptilian ferocity, and mysterious extinction captivating our collective imagination. Yet, as we've journeyed through the ancient world beyond dinosaurs, a compelling truth emerges. Many other prehistoric giants inspire a primal terror that rivals or even surpasses that of the dinosaurs themselves. So, what made these diverse creatures, be they ancient marine predators, massive mammals, titanic insects, or giant flyers, so frightening compared to the familiar narratives of dinosaurs? The answer lies in multiple layers spanning physiology, ecological contexts, evolutionary novelty, and our own psychological perceptions. Firstly, the sheer diversity and unfamiliarity of many prehistoric giants set them apart from dinosaurs in ways that can be deeply unsettling. Dinosaurs, though varied, share common characteristics in skeletal structure and physiology, giving us at least a partial framework to understand their biology. In contrast, creatures like the armored fish Dunkleosteus, the colossal sea scorpions known as eurypterids, or the giant millipedes like Arthropleura present anatomies strikingly alien to modern life. Their monstrous combinations, massive bony armor surrounding explosive biting jaws, or hundreds of legs propelling a car-sized arthropod through primeval forests, ignite an instinctive awe and primal fear stemming from their unfamiliarity. Secondly, many of these prehistoric giants possessed adaptations that presented unusual or extreme predatory efficiencies. For instance, the armored jaws of Dunkleosteus could exert bite forces that rival the largest living predators, combined with a swift jaw mechanism more akin to a modern trap-jaw ant. The Megalodon shark's enormous serrated teeth and powerful swim strokes made it a relentless predator of the ancient seas, unrivaled in its scale and lethality. The ability of Cenozoic and colossal mosasaurs to dominate entire marine corridors through sheer size and speed added layers of terror grounded not just in size, but in their calculated underwater dominance. Furthermore, many of these creatures exhibit gigantism in realms not inhabited by dinosaurs, challenging our expectations of how large life could grow. Giant pterosaurs like Quetzalcoatlus shattered preconceived limits on flight, soaring with wingspans bigger than small planes, while giant arthropods and insects from eras with elevated oxygen uptake reached sizes that seem physiologically impossible today. These giants of the air and land defy the norms, heightening the visceral dread that arises from confronting creatures breaking the known biological boundaries. Another key factor lies in the ecological niches these creatures occupied. Several prehistoric giants existed in environments very different from the terrestrial habitats widely associated with dinosaurs. Giants of the sea, plesiosaurs, mosasaurs, megalodon sharks, ruled vast underwater realms largely inaccessible to humans, fueling fears bound to the ocean's mystery and depth. Crocodilian titans like Sarcosuchus lurked in murky freshwater systems, wielding terrifying ambush predation unseen in most dinosaurian ecosystems. This span of habitats, from deep ocean trenches to swamps and skies, expands the realm of terror beyond land, touching every imaginable biome. The fear evoked also roots deeply in behavior and feeding strategies. Some prehistoric giants, such as the giant short-faced bear Arctodus simus, combined overwhelming physical strength with predatory adaptability, capable of both active hunting and scavenging. The saber-toothed cats and terror birds showcase distinctive weapons evolved for rapid, precise killing, emphasizing the brutal efficiency of their predatory roles. The psychological impact of these cutting-edge killing adaptations, especially when visualized through fossil reconstructions or based on modern analogs, can be chilling. Moreover, several of these ancient beings interacted with early humans or their ancestors, adding layers of real-world danger to their terror. The cohabitation with creatures like giant ground sloths, mammoths, saber-toothed cats, or gigantic crocodilians meant that our ancestors faced threats not just from natural disasters, but formidable animal adversaries. This direct link enriches their fearsome reputations, grounding them in the primal narrative of survival and human evolution. Lastly, the passage of time and extinction itself imbues these creatures with a haunting legacy. Many vanish into fossil record shadows, their massive bodies and brutal habits reconstructed only through fragmented bones, tooth marks, or trace fossils. This partial knowledge stimulates the imagination, creating mental monsters far larger and stranger than fully known animals. They become symbols of a lost world's mystery and danger, figures haunting our nightmares, stories, and deepest evolutionary instincts. In sum, these creatures were frightening, not simply because they were large or deadly, but because they challenged our understanding of biology, survival, and environment in profound ways. Their alien anatomies, predatory effectiveness, ecological dominance in unfamiliar niches, and overlap with human origins combine to evoke awe and fear that transcend even the iconic danger of dinosaurs. As we close this exploration, we recognize that prehistoric giants, whether beneath the waves, across vast plains, or soaring through primeval skies, remain enduring reminders of nature's creative power and its capacity for terrifying grandeur, lessons that continue to inspire, teach, and haunt us today. As we reflect upon the tremendous saga of prehistoric giants, spanning vast oceans, dense forests, scorching skies, and open plains, one question lingers with profound poignancy. Why do these ancient creatures continue to haunt our nightmares, our dreams, and our collective imagination? What legacy have they left that so profoundly colors our perception of the past and even informs our understanding of survival, fear, and nature's extremes? The first piece of this enduring legacy lies in their sheer size and alien forms. Prehistoric giants challenged the boundaries of biological possibility, embodying nature's capacity for extremes that modern fauna can scarcely approach. Their outsized physiques, whether it be a Megalodon shark's serrated jaws, the soaring wingspan of Quetzalcoatlus, or the armored terrors like Dunkleosteus, invoke a primal awe and a deep evolutionary remembrance. Our ancestors, encountering these titanic beings or contemplating their bones, might have felt a mixture of reverence and dread, emotions encoded into human consciousness over millennia. Secondly, the unfamiliarity of many of these creatures fuels the haunting sensation. Unlike familiar modern animals or even the often depicted dinosaurs, many prehistoric giants possessed body plans, defensive structures, or predatory adaptations so foreign that they evoke a sense of the uncanny. Creatures like massive arthropods with hundreds of legs, dragons of the Carboniferous like Meganeura, or monstrous marine reptiles that defy easy categorization into the world of fish or reptiles bridge the gap between reality and nightmare. Their roles as apex predators, or dominant herbivores, often portrayed with vivid imagery, from crushing jaws to imposing sails or massive claws, highlight life's colossal stakes during prehistoric eras. These creatures were not mere backdrops, but forces that shaped their ecosystems profoundly, ecosystems often alien in their composition and function to the Earth we know today. They remind us of the fragile balance and the ruthless intensity of evolutionary competition. Moreover, their coexistence and conflict with our own ancestors introduce a profoundly human element to this legacy. The fact that some prehistoric giants not only survived until the dawn of humanity, but overlapped with early humans adds a psychological and historical depth. Stories of hunting, survival, and even reverence for these creatures have permeated human culture, from cave paintings to oral traditions, blending fact and myth. Extinctions of these giants, often at the intersections of climatic upheaval and human expansion, offer cautionary tales about vulnerability and resilience. They force us to confront the consequences of environmental change, ecological disruption, and overexploitation, lessons deeply relevant to contemporary conservation challenges. Finally, their haunting presence owes much to the enduring mysteries and unanswered questions they pose. Fragmented fossils, enigmatic behaviors, and the vast temporal distances that separate us from their worlds invite continuous exploration and speculation. Each discovery, each reconstruction effort, rekindles the blend of wonder and fear, reminding us that Earth's history is far richer, stranger, and more terrifying than we could ever fully comprehend. In this way, prehistoric giants serve as bridges between science and imagination, past and present, trauma and fascination. They warn, inspire, and challenge us, urging mindfulness toward the forces of nature and the depths of our planet's history. Their legacy is both a haunting and a beacon, a reminder of life's extraordinary potential, its fragility, and the mysteries that continue to dwell in the shadows of time. As we conclude this extensive exploration of creatures scarier than dinosaurs, we carry forward not only knowledge of ancient worlds, but an enriched perspective on the complex tapestry of life itself. A tapestry woven with threads of terror, beauty, and relentless evolution that still echo through our dreams and wakeful wonder.